Okay, so this video is all about exploring what's called the power rule for derivatives, which sounds a lot more exciting than it really is, but here we go. Using limit theory to differentiate a function into a gradient function is tedious. I think by now you'd probably appreciate that. But if we examine closely some particular forms of differentiation, you'll see that there are rules that pop up, and we can use those rules to solve our problems a lot easier. And one of them is the power rule. It's probably the most common one. So to do this, we're going to have a look at a number of simple functions and use limit theory to work out what the derivative would be. And then you'll see from that there is a fairly straightforward rule that comes from that. So let's do it slowly. So I'm going to start off with the most simple kind of function that still has a variable in it, and that is f of x equals x. So I'm going to use that f of x notation. And let's have a look at f dash of x. F dash of x is going to be, oops, should start off by writing it properly. The limit, so f dash of x, remember, is the notation that I introduced last video. It's the notation which says this is the gradient formula, this is the gradient function that we're going to get out of this. F of dash of x is equal to the limit as h approaches 0 of f of x plus h minus f of x, sorry, it's a bit scribbly writing here, all over h. Hopefully by now you're sort of into the swing of doing these things pretty straightforward. So we've got the limit as h approaches 0. Okay, well the function is just x, so f of x plus h is x plus h, and f of x is just x, so it's x plus h all over h, which is equal to the limit as h approaches 0. Well, the x's cancel out, so we've got x minus x is 0, and that leaves me with h on h, which is equal to the limit as h approaches 0 of 1, which is equal to 1, because as h approaches 0, there's no h's that will reduce to nothing, it's just 1. Okay, so when f of x equals x, f dash of x is equal to 1. That's kind of cool. Let's keep going though. Let's try the next power function. So a power function is like something squared or something cubed, or x squared or x cubed, or whatever. So f of x equals x squared, and let's use the limit theory on that one for working out f dash of x. F dash of x is equal to the limit as h approaches 0 of, let's just go straight into it. So f of x plus h is going to be x plus h all squared minus x squared all over h. Let's work that through. The limit as h approaches 0 of, I'm just going to expand that, x squared plus 2xh plus h squared minus x squared all over h, which is equal to, well, let's see, the x squareds will cancel out. That'll leave me with the limit as h approaches 0 of 2xh plus h squared on h, which is the limit as h approaches 0 of h outside of 2x plus h, all on h. The h's cancel out, as is typical for the limit problems here. So that gives me the limit as h approaches 0 of 2x plus h. That's what's left. And now as h approaches 0, this term here just goes closer and closer and closer to 0 until it gets to 0 kind of thing. So we're left with 2x. Okay, story so far. X, f of x. So, that's probably a silly way of doing it. F dash of x. Okay, so far, when f of x, that's a stupid way of doing it. Let's try that again. Okay. When f of x equals x, f dash of x is equal to 1. When f of x is equal to x squared, f dash of x is equal to 2x. I wonder if by now, even just with these two power rules that I've done, you can figure out maybe what f of x equals x cubed might give us. We'll have a look at it anyway. Okay, so f of x equals x cubed. Therefore, f of dash of x is equal to x plus h all cubed minus x cubed all over h. Okay, it's probably worth pausing the video and having a go yourself. You might be wondering, how do I expand that? But don't forget Pascal's triangle, where we've got 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. And that's the expansion of a cube. So that's what you're going to use. So pause the video, have a go at doing it yourself, and see if you can get f dash of x down. But I'm going to continue now and see whether what you got matches this. Okay, so here we go. X cubed plus 3x squared h. So I'm going down in powers of x and up in powers of h. Plus 3xh squared plus h cubed. So that's the expansion of x plus h all cubed. Minus x cubed on h. Now I hope you're seeing that because of the way we expand things, we're always going to have a cube. We're always going to have a power here, which is then subtracted at the end, so that the power without any x's, without any h's, goes all the time, and we're left with one less. The powers left here are always one less than. And if you think of the Pascal's triangle expansion, the second number is always the same as the power. So in x plus h all cubed, the second number here is 3. In x plus h all squared, the second number is 2. So we're getting that sort of pattern coming through here as well. Okay, moving on. I forgot to put my limit in, sorry. If I just chuck it in there. It's naughty of me that I didn't put it in. Limit as h approaches 0. And what are we left with? I might just do this in 2 steps. So I've cancelled out here and here. And I've got a common factor of h. So that leaves me with 3x squared plus 3x h plus h squared all over h. And of course I can cancel out those h's, and that leaves me with the limit as h approaches 0 of 3x squared plus 3xh plus h squared. And of course as h approaches 0, this thing will approach 0 because it'll be 0 times 3x. That's gone. H squared, 0 squared is 0, so that's gone. And so we're left with 3x squared as being a rule. So going back to our little pattern here, I wonder if you figured that out before, that when f of x equals x cubed, f dash of x is equal to 3x squared. I wonder if you can see the pattern yet. F of x equals x, f dash of x equals 1. That might not quite fit the pattern yet until you think about it. F of x equals x squared, f dash of x equals 2x. F of x equals x cubed, f dash of x equals 3x squared. Now I'm going to leave this video here, and I'll start up a new video in a second with continuing on from here and looking at maybe teasing out what the rule is. But I wonder if you know what the rule is yet. So to that end, I'm going to leave you with a question and see whether you can answer it without using limit theory. If I write f of x is equal to x to the power of 10, can you write down what f dash of x is? What do you think it is? Have a think. See if you can look at the pattern and see whether you can see whether you might be able to establish what f dash of x is without using limit theory, and then see if you're correct. I'll see you next time.